Why is it so difficult to return to the moon if we've done it before? This question echoes in the minds of many, evoking images of the historic Apollo 11 landing in 1969. That small step for man was undoubtedly a giant leap for humanity. Since then, however, the moon has remained distant despite our technological advancements. Like a mountain that has already been climbed, the moon now seems like a distant memory in our collective rearview mirror. The last manned mission, Apollo 17, left its marks on the lunar surface in 1972, and since then, the moon has been nothing more than an object of admiration from a distance. This is the starting point of our journey to understand the challenges and complexities of returning to our natural satellite, and here come 3 new astronomy videos every week. Subscribe so you don't miss out. Historical context, the space race, and its motivations. The journey to the moon began not in the vacuum of space, but in the boiling cauldron of geopolitics. The space race was a dramatic byproduct of the Cold War, where the United States and the Soviet Union competed for supremacy not only on Earth but also in the skies. Imagine 2 rivals running a marathon where each step is broadcast to the world, and you will begin to understand the intensity of this competition. Apollo 11 was not just a scientific mission. It was a display of strength and capability. Like 2 athletes seeking to break the same record, the US and the USSR were determined to be the first to leave their footprints on the moon. This historical context is crucial to understanding why the moon landing was so prioritized at the time and why this urgency dissipated after the American victory. Technological evolution and current challenges. Although technology has advanced in ways that would have been unimaginable in the 1960s, these advancements have not directly translated into easier lunar exploration. Imagine trying to use an old smartphone to run modern apps. That's how lunar technology compares to current innovations. The rockets and equipment of the Apollo era were designed specifically for lunar missions, while today's technologies are more versatile but not necessarily better suited for a return to the moon. Moreover, new challenges have arisen, such as sustainability and long-term safety, which were not as prominent in discussions in previous decades. Changes in political priorities and budgets. After Apollo 17, political interest and funding for lunar missions decreased dramatically. Like a river changing its course, the flow of funding and political support shifted to other initiatives. The moon, once the coveted prize in the showcase of space exploration, became less attractive compared to other goals, such as Mars or more distant robotic missions. This shift reflects a new reality where the moon is no longer seen as a geopolitical battleground but as one of many destinations in the vast cosmos. NASA. Today, budgets and projects competing for resources. NASA's budget, while substantial, is a pie that must be divided among many ambitious projects. Every dollar spent toward the moon is a dollar less for other missions, such as Mars exploration or the study of exoplanets. Imagine a juggler trying to keep multiple balls in the air simultaneously. That's NASA with its projects. Moreover, with a budget that is now only a fraction of what it was during the peak of the space race, the agency must make tough choices about where to allocate its limited resources. Technical challenges, launch technology, and fuel issues. While technology has advanced, launching a mission to the moon is still a monumental task. The challenges faced by Apollo missions, such as fuel difficulties and technical challenges, are still relevant today. Each launch is like lighting a giant match, where a small error can lead to disastrous consequences. Additionally, the use of hydrogen as fuel, while efficient, brings its own challenges such as leaks and extremely low temperature management. Technology. Recycling. From the shuttle program to Artemis 1. The Artemis program, aimed at taking humans back to the moon, is not a technological leap forward, but rather an evolution. Many of the systems used are legacies from the Space Shuttle program, adapted for new purposes. It's like renovating an old house instead of building a new one. Some structures and systems are reused, even if they are not ideal for current needs. This approach to technology recycling is both an economic necessity and a strategic choice. Scientific and exploratory reasons. Why haven't we returned to the moon? From a scientific perspective, the Apollo missions provided a wealth of data about the moon. With tons of lunar samples still to be analyzed and much data collected, the scientific urgency of returning has diminished. Imagine a chef with a pantry full of unused ingredients. Before going shopping again, they would like to use what they already have. Similarly, scientists are still busy unraveling the secrets brought back by the Apollo missions. The future of lunar exploration, projects and perspectives. Despite the challenges, the future of lunar exploration is still bright. With projects like Artemis, which aims not only to land on the moon but also to establish a sustainable presence, we are on the brink of a new chapter in lunar exploration. This new chapter is not just a repetition of the past but an expansion, with plans for lunar bases and perhaps even mining. It's like returning to a favorite book and discovering additional chapters that expand the story in exciting ways. Beyond the moon, the new frontiers of space exploration. Exploring the moon was just the first step on a much longer journey for humanity. As a gateway to the rest of the solar system, the moon serves as a stepping stone to more distant and challenging destinations. Additionally, our relationship with the moon has evolved. It's no longer just a destination, but an ally in the quest to understand our place in the universe. International involvement, new countries in lunar exploration. The new race to the moon is much more international than the original one. Countries around the world, such as China, India, and European Union members, are bringing new perspectives and technologies to the table. This diversification not only broadens the knowledge and expertise base, but also transforms lunar exploration from a competition into a collaborative effort. Technological innovations, advances beyond the Apollo program. While the technology used for the moon has not changed drastically, other areas have seen significant innovations. From the materials used in rockets to life support systems in spacecraft, we are witnessing improvements that will make future lunar missions safer, more efficient, and more sustainable. Think of it as upgrading a classic car with a modern engine and safety systems. It retains the essence but enhances performance and reliability. Furthermore, the increasing involvement of the private sector in space exploration is driving innovation and reducing costs, opening up new possibilities for lunar and beyond missions. Cultural and social impact. The moon in popular imagination. The moon has always held a special place in culture and people's imagination. From early tales and myths to the era of space exploration, it has been a source of inspiration and wonder. Now, as we prepare to return, it is reigniting that fascination. Each new mission to the moon is not just a technical feat, it is also a cultural event that inspires the next generation of explorers, scientists, and dreamers. Like a beacon in the night sky, the moon continues to capture our attention and aspirations, serving as a constant reminder of the limitless possibilities of space exploration. Is the moon really the final destination? Exploring beyond the obvious. Is the moon just a stepping stone on the path to more distant destinations in space? This question leads us to consider the moon not as a final destination, but as a crucial stage in the broader journey of space exploration. Throughout history, humanity has always looked to the sky for answers and inspiration. The moon, our closest celestial companion, has always been a focus of curiosity. But now, as we advance in our technological capability, we begin to see the moon as a starting point, not an end in itself. The moon can serve as a test bed for technologies and strategies that could be used in missions to Mars and beyond. Imagine the moon as a laboratory where we can experiment with life and work in space, preparing ourselves for longer journeys. Lunar conditions offer a unique opportunity to test life support systems, habitats, and other crucial technologies for long-duration missions. Additionally, the moon can serve as a launch point for deeper space missions, providing advantages in terms of gravity and launch costs. The renewed interest in the moon also raises questions about its resources. There are discussions about mining lunar resources, such as water, which can be used for life support or converted into rocket fuel. This could transform the moon into a sort of space gas station, crucial for exploring more distant destinations. This perspective opens a new era of space exploration, where the moon plays a central role in expanding human presence in the solar system. Unsolved mysteries of the moon. What we still don't know. Despite decades of research and exploration, what mysteries of the moon still remain untouched? The moon may seem like an open book in terms of space exploration, but it still holds many secrets waiting to be discovered. One of the biggest enigmas is the moon's origin. There are several theories about how it formed, with the most accepted being the giant impact hypothesis, which suggests that the moon formed from the debris left behind after a Mars-sized body collided with Earth. However, there are still many unanswered questions about the exact details of this event. Another mystery involves the moon's composition. While the Apollo missions brought back valuable samples, they came from a relatively small area of the lunar surface. The moon has a variety of geological features, including lava plains, mountains, and possible ice deposits at the polar regions. Each of these areas may offer new insights into the moon's history and, by extension, Earth's. Furthermore, the moon has a side that is never seen from Earth, the so-called far side of the moon. This region remains relatively unexplored and may contain crucial clues about the early history of the solar system. Missions focusing on the far side of the moon could reveal new insights into the lunar geological history and even early solar activity. Choose your next video now, and I'll see you there.